Well, hi, and welcome to my shop here. It's December 5th, and I'm ready for another shot at this radio. Something interesting is going to show up right away. But before that interesting thing, have a look at this. I was talking about my earlier days working in a power company, and I was showing some pictures on a video of big electrical splices being made. And when they make those splices, they use solder like I use solder. Well, not like I use solder. Look at my solder. Here's their solder. That's what they use. They buy these things in lengths of bars. This one's cut. It's probably about that long when new. And they, it says right on it, 40, 60. It's 40-60 solder. And not the same as this stuff. And of course there's no rosin in here or whatever. This is a solid piece of metal. Take a big pot, put a blowtorch, a big metal pot, put a blowtorch, a steel pot of course, put a blowtorch on the bottom of it, blasting away, and start dropping these in and melt them. Maybe 20 of these to make a pot of molten solder. And this is what I use for my soldering. Thought you'd get a kick out of that. I came across it yesterday in my house and thought, well, I might as well show it. Might as well show and tell it. Okay, now, the interesting thing about this radio. So I've tested the tubes and discovered quite a few of them are weak. In particular, the output tube was unsatisfactorily weak. How disappointing is that? I've also noticed that the cathode resistor is burned a little bit. Well, that kind of thing happens now and then. Also, when I went to test this tube, I noticed I couldn't read the tube name. But we are going to read it in just a moment. Are you getting where I'm going with this? So this is supposed to be a EL95, a somewhat rare tube, and a tube that doesn't have a commonly available North American version of. At least I certainly don't have one. Let's look at this a little closer and see if we can read what it says on it. I'm going to flip over to my close-up camera here, and I hope this comes across. Let's see how we can do here. So we're looking for the number of this tube, the name or the number. So it's coming into view there. See the word Japan right above it. I may not be able to get this on the video, unfortunately. Let's try this angle here. So I have a magnifying glass, a pretty good one, and I often, there you can start to see it. So 6AQ5A. There the A, you can see the A fairly clearly. 6AQ5? What's that doing in there? Well, this could be a perfectly good 6AQ5. I tested it as if it was a EL95. 6AQ5. What's going on here? How do you expect that to work? That's what we're going to look into today. What in heaven's name did somebody try? When I get these radios, once in a while, the tubes are all mixed up. They've been moved around and just stuck back in wrong. And once in a while, they have a wrong tube in them. Like this one. So we got to look into this. 6AQ5. The best way to do this, I think. I'm going to start. I'm going to have to look up an EL95. I don't think I can do it with this book. EL95. Well, we'll put that on the screen. But first, I'm going to get on the book here a 6AQ5. I have a lot of 6AQ5s, I think. 6AU, 6AQR, 6AQ5. There we are. Beam, power tube. Yeah, it's definitely an output tube. No doubt about that. Oh, son of a gun. I got my phone in my pocket again. So the problem with my phone in my pocket is it interferes with the video, and I don't know it when I'm standing in here, but you'd hear that usual stuff. So I apologize if there's that stuff on my video here. So this isn't really going to help me. Wow, it's a long write-up on it. Use of type AQ, look at this, right off the bat here. Use of type AQ5 in a series string arrangement. That's what's going on in this tube. Should be limited to tubes with the same heater current rating. Well, that's for sure. It's necessary to use a 6AQ5 in series with tubes having different heater ratings. Shunt resistors are required. Look into this. Cathode of a 6AQ5 should preferably be connected directly to the electrical midpoint of the heater circuit when the heater voltage is supplied from a transformer. It is oh, you know what, this is a transformer. You know, what am I thinking? I work on too many radios. These are not in series. So this is hooked up to a transformer, 6 volts. So not in series. Connected to the electrical midpoint of the heater circuit when the heater voltage is supplied from a transformer. When the 6AQ5 is operated in receivers employing a 6-volt storage battery for the heater supply, its cathode circuit's tied directly on. Where do you care about that? Under any circumstances, the heater cathode voltage should be kept within ratings. If the use of a large resistor is necessary in some circuit designs, it should be bypassed by a suitable filter network or objectionable hum may develop. In all services, precautions should be taken to ensure the dissipation rating is not exceeded and expected line voltage variations expected in cases of fixed bias operation when the push-pull connection is not push-pull. Wow, okay, lots of stuff to think about with this one tube for some reason. But the main thing is, what the heck is it doing in this radio? That's really the question. So we're going to look at the pin-out arrangement of the 6AQ5 and compare it to what is supposed to be in there. My gosh, okay, let me get this stuff on the screen here. We can look at it properly. Okay, so doing a little research on the tube situation here. I made these two diagrams. Turns out the pinout of a 6AQ5 is the same as an EL95. EL95, but there are some dramatic differences between these two tubes. And popping this one in just as a direct replacement for this one, probably not going to work well. There's a problem with the amount of current that this tube wants to draw. It's about double what this one wants to draw. The cathode resistor for this guy, the 330 ohm cathode resistor, something different has to happen over here, or the resistor will burn up, will overheat. That one didn't burn up, but it overheated. But I did find a really interesting discussion here. Highlights to me again about how wrong I was about my vision of where I'd be today. When I was a younger man, I thought by the time I got to the age I'm at now, retirement age, that I'd be like 1 of 10 people in North America who knew anything about these radios. Well, that's how it looked to me back in the 80s. That it really looked that way. But here I am now in 2020, and it turns out I'm surrounded by people who have more expertise than me. I have a lot of experience working on these things, years and years of it, but in terms of technical, deep understanding, I'm not at the top of the heap here. I'm not at the front of the classroom, that's for sure. And you know, with the advent of the internet, everybody can know everything about anything, and that's what's happened. So it's easy to find expert discussions. I mean, you know this, right? We all know this now. The world is so different than what it was and what I thought it would be. Nobody told me the internet was coming. Let's take a look. Actually, yes, they did. I invented the internet, but I won't go into that discussion right now. So let's take a look at this information I found and read through it quickly. So this is coming from Radio Museum, great site with all kinds of information, but also lots of discussions. This fellow here appears to be a real expert in this particular topic, substituting EL95, so we're finding substitutes for it. So yeah, so this is the one, if I had one, we would use right away and be happy. Change the resistor to 270, be really happy. Look at this one. So these are two possible replacements, an EL90 or a 6AQ5. Maybe they're exactly the same, 6AQ5, EL90. Less recommendable since their rated plate current of 45 milliamps is almost twice the rated plate current of an EL95, which is 24. One could choke down the EL96 AQ5's plate current to 24 by increasing the cathode resistor. But this moves the tube into a non-optimal operating range with increased distortions. As for the heater current, refer to the 6BM5. Okay, 6BM5. One should take into consideration the heater current is 0.4. Yeah, you have to compare it to a 0.2. So we're doubling the heater current on one of 5 tubes. So that's what? That's like a 10% increase in overall heater current. Probably not going to do any harm. Well, so it could be that the 6AQ5 that's in this radio is worn out as a 6AQ5. It tested low as an EL95, which is a hint that it's not the greatest replacement. We're going to put it back in the tube tester and test it as a 6AQ5. By the way, this is a 6AQ5A, and there's a substantial difference in the way the heater is taken care of inside the tube. The earlier version of the 6AQ5, the heaters were a little bit precarious, and then they were strengthened. They could take a little higher, not supply voltage, but inter-electrode voltage. The one I've got is an A, type A. Now let's go test it. Okay, let's test this guy as a 6AQ5. Oh, better double check. Here. 6.3. Signal level 2. 36H. For bias 51763. 51763. 4G00. 4G00. Be interesting to compare these settings to the EL95 settings. But there are no EL95 settings. So, here we go. So this tube tested really low in the tube tester, yet that radio produced enough volume that it made me wonder about it a little bit there, because it seemed that the tube tested as low as it did, it wouldn't work at all. That's what I would think. Of course, the test was invalid because I'm testing a different tube. But it's interesting to sort of consider substitutions by setting your tube tester up for the tube that's original and then plugging in the substitute tube and then seeing how it responds under that condition. Is that really valid? Not so much, I don't think. But interesting it would be. Oh, we gotta turn this on for crying out loud. Interesting would be what it is. Interesting things interest me, so okay. Any shorts in that tube? So this tube is showing a short on 1. Now that could just be a normal thing. So this is a 6AQ5 setting here, and it's a 6AQ5A. Normally I wouldn't think there's any particular difference. So now we're stuck here with this tube tester telling me there's a short in this, but it's not a dead short. It's 200,000 ohms. That's just... Well, you know what? I happen to have another tube tester right here. Let's stick it in this one and see what happens. So this would be a 6AQ5. A 6AQ5. Okay, so 6.3, 237, AC156, AC156, 38 on the big wheel. W for the test. Okay, so we're going to come right out of this tester, 6.3, and right into this one. Keep the tube hot. Now, shorts. Watching the light on this one. I don't think it's warmed up yet. I don't think I've turned this on. I have not turned it on. Yeah. You'd think by now I would have learned enough, you know, to turn things on. But no. Okay, shorts now. Watching the light. Typically, this light should flash a bit from charges on the tube elements. I got this right? 6AQ5 237 AC156. Well, I see the tube heating up. I don't see it heating up at all. Let's give it the test. W. Boom. What's going on here? Something's up. Something's not quite right. So we watch the pilot light. I will wiggle the tube, and if the pilot light fluctuates, I know the tube heaters are making and losing contact. This tube is warm. So I see nothing happening here. Next possibility is a socket problem. It's just not making contact with the tube. So we'll push the W test button, 6AQ5, and we'll wiggle the tube. Let's see if no. See if it jumps up into the good. It's rising up now. What the heck does this mean? It's rising up all the way to bad. Oh my gosh, now a short is showing up. Why didn't that show up earlier? Because the tube was not in the socket quite right. So we've gone from a 6AQ5 bad substitution for a tube to a bad 6AQ5, a really bad substitution for that tube. What happens if I get a good 6AQ5 and stick it in there? So I have to do a little more reading before I follow along with whoever did this before. There could be that some changes had been made to the radio. I don't think so, though. I think what they did was they just stuck this in, and you know, maybe it worked okay for a while. Yeah. So this is for yeah, right. Okay. Let's see if I can complete a sentence here. What is the size of the resistor required for the 6AQ5 cathode? It's the same as a 6V6 apparently. So under 6V6, if we look for a, let me find it easier to look over here for ohms. Am I going to give a cathode resistor? Come on, please, give me one. Give me one, anyone. No cathode resistor. That's not going to help. Okay, well, that didn't work out. Thought I could get a notion of what size. Look, I can do a little more research on this before I stick another 6AQ5 in there and just kind of burn it up for some reason. Interesting. It's an interesting situation. 6AQ5 is not considered a direct replacement for this tube. It's not recommended anywhere. But we read what we read. I'm going to read some more. The situation here has become annoyingly complicated. So I have the wrong tube or a poor substitute in the radio, and it turns out the substitute has a problem itself. What I want to do right now is I just want to so this is set for a 6AQ5. I'm going to set this for an EL95 and see what the difference is, if there is any difference. It's just kind of a very crude way of comparing the two tubes. So EL95, put it this way. EL. So if these tubes were identical, the settings would be identical. Nothing would change. So it's same voltage, obviously. In this tester, they want a higher signal level for the EL95. Now, the bias 16H. So you see it's on H, it's up much higher. 16 is way down here, so about double whatever that means. In reality, 51763, 51763, these have to be identical. 4G00, 4G00. So the pinout is exactly the same. Meter sensitivity for the EL95 should be 38. Here it's almost the same. It's 33 here. Half, of course, same plate. So, you know, quite clearly you can pop a 6AQ5 in where a EL95 was. But problems will ensue. And that's what I want to try to work around. I'm going to assume maybe the low volume in the radio was due to the defect in the 6AQ5. The interesting thing is, when I tested the 6AQ5 as an EL95 by accident, the short didn't show up. So it's just possible the short, and it's hard for me to understand, but or to believe rather, the short in the tube may have no impact on this radio, but in another radio that shorted tube may cause a problem. I don't know. I'm going to think a little more about this before I do anything. Okay, let's see some of these 6AQ5s. 6A. So they'll be in the bag. Here we are already. Here we are. 6AQ5, 12AQ5, and a 5AQ5 in there. Okay, so these have all been tested in that the heaters are good, the tubes function, whether they're, you know, top of the line tubes. No, I have to test them. I have to test it, test the one I want to use. So you just have to pick one. And should I pick a 6AQ5A or a 6AQ5? I think we should pick the A, assuming I have a choice, because the 6AQ5A is a better tube. That's all. Okay, let's see. If I pick two, they look nice. Let's see if they are. Just do a little line check here. Okay, watching for a leak up here. Nothing happening. Test 6AQ5. It should come up to 1200. So 1200 would be about there. So there we are. So I've already got a good 6AQ5. I don't really have to go any further. Put this one back. Now, I guess the word would be reticent to put that into the radio, even though there was one in there, because I still haven't read enough about what maybe should be done to this radio before you try to operate it with this particular tube. So I'm going to put this right here. Now I got to put an X on here, or I forget. Okay, so I'm keeping it in my hand, and got to do a little more reading here. Okay, so I've continued reading up on this 6AQ5 tube. There's quite a lot to read about it. It's really a miniaturized 6V6. That's really what it is. Okay, so what I'm going to do here is I'm going to test it using the settings for a EL95, which I've got set up here. I've already checked it. So I'm going in. What's going to happen now? So I guess in a way, the tester's going to tell us how well can a 6AQ5 tube work as an EL95. Now, it's really pushing what you can do with one of these testers here. So let's just look for shorts. Nothing. Okay, 6AQ5 as an EL95. Wow. Okay, so just threw my meter right over. So one of the big differences here is the bias. Now, if I set the bias here for a 6AQ5, let me just find where it is here. 6AQ5, here it comes. So the bias should be 36, so it's 15, it should be 36. Now what do these numbers mean exactly? I don't know. There's a switch here, H and L, high and low, I imagine. Exactly what's going to happen, I don't know. I'm going to vary this all the way to 33, and we'll watch what happens. In fact, I don't want my needle pinned over so hard, so I'm going to guess, having this up, I'll put it on 25, will keep the needle from hitting the... Good. Up and down. So, if this tube encounters the kind of biasing that would be set up for a EL95, you get this kind of reading. Certainly isn't crazy off the scale. What does this really mean? I'm not sure. I'm not sure. Just doing this for interest's sake. So in the radio, operating this tube, oh wow, it's gotten hot already. Operating that tube in the radio safely, I think involves a couple things. One is having the tube in the circuit and measuring the cathode resistor voltage drop and determining what the bias is on the tube. That's number one. I think that's number one. You know, what I would be worried about is the old 6AQ5 behaved differently because it has a defect in it. I mean, this is a bit of a long shot here. And putting a nice new strong 6AQ5 is going to make smoke come out of this resistor before I can test it and save it. The typical bias resistor for a 6AQ5, I don't know what it is. I think something higher than this is needed. This is a 330 and I think a 370 is what you need, or maybe it was a 270. I don't know yet. So I think the best thing is find out what happens in this circuit. Somebody's already stuck a 6AQ5 in there, and I already ran this radio with a 6AQ5 in there. Which, you know, I'm not able to test to find out how strong the tube is. So the original tube, which I think is the cause of the low output, may be as strong as the one I'm going to put in. We don't know because of that short. Oh my gosh, simple things become complicated, eh? Okay, let's see how this goes. So this is the 6AQ5A I just tested. I have to actually put it in, not just throw it at the radio channel. So I have a voltmeter of this guy hooked up across the cathode resistor there. And then I have this heat viewer set up. You can see the red stuff is the tube. And I'll show you by sticking my finger here. That's where the resistor is, right at the end of my finger there. So of course it's not showing up now because there's no heat in it. Things turn red on here when they're higher than 25 degrees C. I'm going to change that setting and make it 30. So you can see the red just disappeared, and that's from the tube. You should still see my finger in here though. It's very hard to get this to appear on the video you're watching. So I think I got it now though. So the objective is I turn the radio on. If this tube is going to blast this resistor, we'll see heat in it pretty quick. As soon as the heater is warmed up on this tube and the B plus is available, B plus is being rectified by a silicon rectifier, not a silicon, but a solid state rectifier, so it's going to be available right away. So as soon as the heater heats up on this thing, current's going to flow and this resistor is going to start warming up and this voltage is going to appear. So the objective of this test is to measure this voltage without burning up what's left of the resistor. And the reason I'm concerned is a different tube in the radio. what's probably going to happen, I'm probably going to turn it on, everything's going to be just the way it always was, nothing unusual is going to happen. We're going to read a voltage on here of something like 8 volts. Put your money down, 8 volts. Put your money down on what you think the voltage will be. That's my guess. So order of operation here, staring at this at first, just because it turns red here doesn't mean some disaster has happened. I mean, the tube is going to turn red on the screen here right away almost. What we need to do is read the highest temperature. You know what I'm going to have to do? I'm going to have to shield this tube from the camera so that the automatic highest temperature pickup on the screen here will be from the resistor, not from the tube. The tube is going to get really hot, so I do need to block this from view. Now then, you can't see it in the camera, but there's a little number written here in red that shows the highest temperature. Like right now, the highest temperature on the screen here is 28.5 jumping around my finger. You can't see it, but there's a little red plus sign. You can see the white one here maybe in the middle. You can't even really see the white one. There's a white one fixed in the middle. Then there's a red one bobbing around marking the highest pixel temperature, and another one over here bopping around marking the lowest temperature. It's really a neat instrument. I'm going to have to block this. It just has to be kind of a temporary thing, nothing too serious like this. And we'll use a piece of sandpaper. Now, why would you pick sandpaper? Because it was there. Perfect. Okay, so now anything we see showing up here should be that resistor. Where is it again? On the screen. It's just below the middle, right in here. We're looking for red. Everybody ready? Radio's plugged in. Volume is turned down. Put the radio on broadcast. And I see my clip lead has popped off. Okay, hold it. We have, it's really hard to clip onto the little tiny lead here. And we have to do something else. Yeah, I don't think this is going to work. Son of a gun. It all comes down to a clip lead. Oh, I got it there. That's good. That's good. That's good. Okay, 3 times. That's good. Ready now? You're ready. Okay. Doing this through the dim bulb. The dim bulb light, which is back there. Just to ease off the pressure ever so slightly on this radio. There we go. I'm watching. Okay, so the red plus is already settling in right in here. It's popping around now. Okay, so we're getting a voltage coming up here. What did I say? 8? I guessed wrong. We don't see any heat in here yet. What do we hear coming out of the radio? Oh, it sounds like my soldering iron, but it's not on. So we're getting a little bit of heat building up here now. The high temperature indicator is sitting right there. 33, 34, that's nothing yet. You can see the heat is coming right through the, I can block it with my hand, it's coming right through. So, tin foil, no good. Now I just touched this and I heard what did I hear? Phew. Wow. My gosh, I thought I had straightened all that out. Look at that. Son of a gun. Wow! Jeepers. Sounds like the radio's still working. Let me tune it here. It's definitely picking stuff up. It's still noisy when I turn the volume down, so the noise is coming after the volume control. Yeah, it's just these two guys. My gosh. Okay, lots of red on here now. Some of it's going to be this other two. Oops. And isolate away the... Oh, listen to this radio. Oh, holy smokes. Piece of paper made it change? What happened there? I must be moving the tube a bit. There's the resistor there. I'm just trying to get rid of all the red. Yeah, I did it. I did a good job of it right there. Still sounds like it's working. My gosh. Okay, so the task at hand. We have 9.5 volts on a 6AQ5. The temperature of the 6AQ5, which is, I'm sure, the hottest thing on here, 166 degrees C. It'd burn the skin off your finger if you touched it. Now, you got to take these readings with a bit of a grain of salt, because there's issues here with emissivity, and even the heater in there, which you can sometimes see with your eyeball. You can see the red heater. This thing can see it too. So you really got to have your thinking cap on. But I think the basic rule here is this resistor is not getting too hot. Let me try one more check of that. Get something a little more. You know, I don't have to block its view right down at the thing. I can block its view up towards the camera here. And try to leave the resistor in view. Is that the resistor? You touched it. Fooled here. What's all this stuff? So that's my hand in the bottom right part there. There's the resistor. The resistor is here. What exactly this is? So there's the resistor there. Yeah, for sure. So if I move it, he can't see it maybe, but there's a white plus sign. If I get it right in the middle here, just come on, don't make this so tough for me. There we go. 41 degrees. Oops, that's nothing. That's nothing. 41. 90 is something. 41 is nothing. Now, can I try to double check this? Yes, with my finger. This is a really bad way to do this. I need some reality here. There's no heat in that resistor at all worth worrying about. Again, bias voltage 9.5. So let's just check. I don't know if I can find out what a typical could be. 6V6. 6V6. It's the same thing. 6V6 Grid number 1 control voltage. 480 volts B plus minus 8. 250 minus 12. So we're in the realm. We're in the realm here. The fact that it's a plus reading just has to do with how I hooked up the meter. So should I be really concerned about that tube that's sitting in there right now operating? Hard to say, because there's a couple factors here. Plate current, I don't know what it is. Plate current in these tubes is much higher than the plate current in the tube that's supposed to be in there. Higher plate current drawn through the output transformer. Heavy current would heat it up. Let's take a look at that, for crying out loud. For crying out loud! Oh, there's something up there that's got some heat in it. Now, how much heat? So use the white plus sign right there. So something's 50. Highest number I'm getting there is 50, 51. I think I saw. Sure looks like it's a transformer. Now, so you expect some heat in it. 51 is a little high. Big transformer take a long time to heat up. I'd love to stick my finger up there and touch it, but not with the B plus that's going up there. Don't think I want to do. I can't see well enough. Maybe I can. Yeah, maybe it's not good enough for getting a shot. Excellent. Now how about the volume? Well, lots of volume right now, but who knows what's going on with these tubes and their weird contacts. How come so stable now? It's stable because this doesn't seem so good. You could have a part like a resistor with a fault inside it, and as the resistor heats up a bit, the fault closes up and goes away. So you can get, depending on how long you operate the radio, how hot it gets, different things doing different things. Let's pick something up here. Well, that sounds really good.
Ouais, ça va pas très bien à Saint-Jérôme. Vous êtes au courant de la situation là-bas?
Ben, c'est sûr qu'on l'a suivi parce que veut pas, on est très liés. C'est notre centre de référence pour nos patients.
Ah, okay, that's really good.
Par exemple, une cheville ou un poignet à Mont-Tremblant, on va vous replacer votre cheville, votre poignet, mais ensuite la chirurgie va se faire à Saint-Jérôme. Donc c'est sûr que étant tous interreliés comme ça, c'est important que ça.
So the voltage it's running with right now is only 100 volts. Okay, so everything's going to go up. This is going to get bigger. The temperature is going to go up. We got to do it though.
Une journée sur un plancher d'hôpital dans un contexte de COVID où il y a des mises en garde de débordeurs.
Ça ressemble à une très très longue journée. Puis à des semaines un peu interminables.
I got minus 12, which is also right in the range, according to the manual. I'm going to try
Avec des appels de soir, de nuit, des patients qui rentrent. À travers ça, il y a un petit peu de gestion pour être capable de s'assurer que la répartition des patients à l'intérieur de l'hôpital est correcte, les isolements pour les patients qui sont à risque.
So that's where the chick-chick is coming from. It's coming from here.
Des cas de COVID rapportés qu'on veut isoler pour être bien certain tant que si longtemps que leur
Yeah, lots of red, right? So I'm going to raise the red limit here.
Il est critique aussi cette vigilance-là pour être bien certain qu'on n'est pas face à des éclosions à l'intérieur de l'hôpital. Donc ça ressemble effectivement à de l'oxygène, ce genre de l'oxygène, et ce genre de l'oxygène.
Now I'm going to use a blocker to try to figure out what we're looking at.
Certainement, donc c'est important de se prévenir contre ça, c'est garder un peu de temps pour reposer, réduire la tendance, dormir.
All two. The resistor is this little green spot right down in here. Okay, I don't even speak French, so why am I listening to that so much? Try to block as much of that away and then get a reading right down there. So we're seeing up around 60 now on the resistor. 60, not, here, let's try another one. Now, this is a cat calling machine because it has a beep in it, and usually when I do this, it has a laser. So guess what? It's a cat toy, right, as far as the cats are concerned. So I squeeze the trigger, this thing's going to beep. I may have 2 cats outside my shop. We'll try this. This is a terrible way to do this, by the way. So we get 45. Well, what makes it a terrible way to do it is that you know, this is taking the average of whatever it is it's seeing. So in there is a resistor. So it's taking the temperature of the resistor, but it's averaging it with everything it's seeing. 45. That's why I like to touch these things if I dare. And that really lets me know. 45 is ouchie. Yeah, there's so much heat coming off this tube. When I get close to it, I feel the heat. Okay, so I don't know. I think it's okay still. How it got blackened like that? It would have to get a lot hotter, I think, than what it is. Tricky to angle this right. 60 degrees still. It's seeing something hotter up in the back there. What's that? Not sure what it's seeing there. I'm looking at this, which is relating up in this area. There's a fuse right there. Is the fuse one? Tricky to use these because at first it's very wide angle. It's seeing a lot. Okay, so 12, not too hot to cry over. So you're not supposed to be able to do this. Just pop a 6AQ5 in successfully where one of those other tubes was, but there it is. So I think we've kind of jumped right past the problem here. We've got lots of volume now. The distortion's gone. Thumbs up on that. Okay, great. I'm going to stop now before I find out it's not true. So thanks a lot for watching. And I don't know what I'm going to do tomorrow. Oh, I still got capacitors to change in there. Yeah. See ya.